Good afternoon, everyone. Energy is a prominent role in all the lives of people. So, how far are we saving this energy? Not truly correct, but yes, we have to make an attempt of it because we are depriving of this energy source. So here is a solution amongst us. Today we have Dr. Chandrasekhara BM, Associate Professor and HOD, Department of Chemistry from Bangalore Institute of Technology, who is here to address us among the alternate energy resources, the current scenario and future challenges. Sir, on behalf of the VVC management and from Department of Chemistry, I formally welcome you for this session. Over to you, sir.
Thank you, madam. Thank you for the introduction. In this presentation, I will be discussing about alternate energy resources, current scenario and future challenges. We all depend upon energy for each and every activity. We can't imagine life without energy even for a single day. Actually, the quality of life is measured in terms of energy consumption. Even the economy of a country is linked to the energy consumption. In case of developing countries like India and China, energy demand is increasing year by year rapidly. Whereas in case of developed countries, energy consumption is almost at the maximum level, and from there it is increasing slowly and gradually. Here you can see the global energy consumption. Projections up to 2030, you can see here. You can see the very gradual increase in the energy consumption from year to year. Energy consumption has increased almost 2.5 times from the year 1980 to projections up to 2030, and on an average, energy demand is increasing at the rate of 1.8% every year. Let us see from where we are getting this energy from. This is the world energy scenario. So out of the total energy what we are using today, about 31% of the energy it is coming from crude oil. And next major contributor is coal. Coal is contributing about 26% of energy. Natural gas is contributing about 23% of energy. And about 9% of energy we are getting from bio-waste materials. And remaining 10% we are getting from nuclear, hydro, wind and solar power. You can see here the contribution of renewable source of energy like hydro, wind, solar energy, it is only about 5%. The remaining 5% we are getting from nuclear energy. We all know the dangers associated with the nuclear energy. And here about 90% of the energy we are getting from the carbon containing resources, that is crude oil, coal, natural gas and bioenergy. Out of these resources, the biomass energy, we can consider it as a renewable source of energy. But even then, biomass what we are using today, we are using only biomass for the domestic heating purpose, where lot of pollutants are locally released into the atmosphere. Therefore, even though biomass is a renewable source of energy, we are not using this biomass effectively. One of the fuel what we are using here is crude oil. Crude oil is contributing about 31% of energy. And this crude oil is non-renewable source of energy. These energy resources we are mainly using for the power generation purpose, for the transportation purpose, for the industries and for the domestic heating purpose. One of the major drawbacks of the fossil fuels is all the fossil fuels, they contain carbon. They release carbon dioxide into the atmosphere on combustion. Along with carbon dioxide, oxides of nitrogen, oxides of sulfur and volatile organic compounds are also released to the atmosphere. As you all know, carbon dioxide is the main gas responsible for the global warming. About 55 billions of carbon dioxide is released annually into the atmosphere due to combustion of carbon containing fuels. Therefore, the concentration of carbon dioxide, it is increasing gradually and slowly from year to year. And presently the concentration is around 408 ppm. This increasing concentration of the carbon dioxide in the atmosphere It results in global warming. Another major drawback of the fossil fuels is these fossil fuels are non-renewable in nature. The crude oil what we have today may last for another 30-40 years. And by that time, we need to find the alternatives. And whatever the alternative energy resources we are going to find, they should be renewable in nature and they should be environmental friendly. Lot of research is going on about finding the alternatives. And alternatives what we have today can be classified into carbon containing alternatives and non-carbon containing alternatives. See, containing alternatives, even though in short term they may replace the present day fossil fuels like petrol and diesel, but the main problem with the carbon containing alternatives is they also contain carbon. They will also release carbon dioxide into the atmosphere on combustion. Therefore, the real alternate energy resources should not be containing any carbon. And if we can find a real non-carbon containing alternatives, then we can make this world pollution free. Therefore, while discussing alternate energy resources in this particular presentation, I will be discussing how to make this world pollution free. See, as of today, if you can imagine a world where there is no pollution, where no pollutants are released to the atmosphere, where vehicles run without emitting any pollutants into the atmosphere, all these things seems to be impossible things now. But all these things can be achieved with the help of these alternate energy resources. And in this presentation, I will be discussing how to achieve these goals of zero emission, pollution-free world with the help of alternate energy resources. And what is the role of chemistry in achieving these particular goals? Let us first discuss about carbon-containing alternatives. As I said earlier, petroleum resources what we have today may last for another 30-40 years. But we have other carbon containing resources in plenty. Coal is available in plenty. The coal stock what we have in India today may last for another 250 years. And biomass is also available in plenty. And biomass, in fact, it can be considered as a renewable source of energy. Therefore, the carbon containing alternatives are those alternatives where this coal and biomass are converted into liquid fuels, and those liquid fuels are used as alternatives to the petrol and diesel. But major drawback of these fuels is all these fuels again they contain carbon. These are the chemical routes which are available as of today for converting the solid biomass into liquid fuels. Biomass, similar to the petrol and diesel, it also contains carbon and hydrogen. But the main problem is, in addition to carbon hydrogen, it contains a lot of oxygen. Therefore, the chemical bonding in the biomass molecules, it is highly complicated. Those are very big molecules. They exist in the solid state form. And biomass, which is in the solid form, it can be converted into liquid fuel form through various chemical reactions. These are the 4 catalytic routes which are available for converting biomass into liquid fuels. The first route is converting the oil resources which are present in the biomass into biodiesel, which can be used as fuel in the diesel engine. The second route is gasification of biomass directly into synthetic gas, and synthetic gas can be converted into liquid fuel through the Fischer-Tropsch synthesis process, and that can be used as fuel in the petrol and diesel engine. The third route is conversion of the biomass in a biochemical manner by subjecting biomass to fermentation, forming alcohols, and alcohols on catalytic conversion, they can be converted into liquid fuels. The last and important route is conversion of the biomass directly into liquid fuels through various catalytic processes. Let us see these catalytic routes one by one briefly. The first one is conversion of biomass into liquid hydrocarbon fuels. These are the catalytic routes available today for conversion of the solid biomass into liquid hydrocarbon fuels. The lignocellulose biomass, it can be converted into bio-oils by subjecting it to pyrolysis or hydrothermal liquefaction. And bio-oils on hydrotreatment, they can be finally converted into aromatic and aliphatic hydrocarbons. Lignocellulose biomass, in the other route, it can be converted through hydrolysis into glucose and xylose. And glucose and xylose on hydrogenation, they result in the formation of sorbitol and xylitol, which on hydrodeoxygenation reaction result in the formation of aliphatic hydrocarbons with carbon number 5 to carbon number 6. This glucose and xylose, in the other way, it can be subjected to dehydration, resulting in the formation of HMF and furfural. And these smaller compounds on carbon-carbon coupling reaction, they are converted into various intermediates. And these intermediates on dehydroxygenation reaction, they are converted into C8, C15 hydrocarbon molecules. In another catalytic route, lignocellulose biomass can be hydrolyzed directly into lignin, and lignin can be subjected to depolymerization reaction, resulting in the formation of phenolic monomers and dimers. And these phenolic monomers and dimers and hydrodeoxygenation reaction can be converted into aromatic and cyclic aliphatic hydrocarbons. These are the catalytic routes which are available for converting biomass into liquid fuels directly. There are major challenges. Even though these are the academic research results available, these reactions are not yet commercialized. There are major challenges which need to be overcome before commercialization of all this process. One of the major drawbacks is the hydrogen requirement for the majority of the reactions which are carried out here. For the majority of the reactions which are carried out in the conversion of biomass into liquid fuel, it requires hydrogen. So hydrogen is a secondary source of energy. We don't have any primary source of hydrogen. Therefore, hydrogen which is produced in some other chemical reaction should be used here, which increases the cost of production. That is one of the major drawbacks of converting biomass into liquid fuels. Another major drawback is catalyst deactivation. Here you can see here in the conversion of biomass into liquid fuel, one of the major reaction is hydrodeoxygenation reaction, which is a catalytic reaction. And this reaction goes in parallel with the polymerization reaction. And in fact, in some cases, polymerization reaction occurs at faster rate compared to the hydrodeoxygenation reaction. And whatever the polymers are formed over here, those polymers, they result in the coke formation and they deactivate the catalyst. Therefore, catalyst deactivation is one of the major problems what we are facing today in the conversion of biomass to liquid hydrocarbon fuels. Therefore, we need to find a alternative, a very good stable catalyst which can effectively carry out this hydrodeoxygenation reaction to obtain the liquid fuels from the biomass. Another major drawback is majority of the reactions which are reported in the literature, they have taken the standard compounds for studying the chemical reactions. They have not taken the original lignocellulose biomass. And original lignocellulose biomass, it is obtained from various resources. And biomass obtained from different resources will be having different properties. Therefore, we need to study the biomass obtained from each and every resources and how we can convert effectively that biomass into liquid fuel. The second main chemical route for conversion of the solid carbon material into liquid fuel is by Fischer-Tropsch synthesis. We have coal, biomass and natural gas in plenty. And the carbon present in coal, biomass, natural gas, it can be converted into synthetic gas by means of reformation reaction in the presence of nickel catalyst. By passing the water vapor at very high temperature, the carbon present in coal, biomass and natural gas can be converted into synthetic gas. Synthetic gas is a mixture of carbon monoxide and hydrogen, which is the main reactant used in the Fischer-Tropsch synthesis process. And by Fischer-Tropsch synthesis, using the catalyst like nickel catalyst, cobalt, ruthenium, iron-based catalyst, the synthetic gas can be converted into various hydrocarbons. And these hydrocarbons are liquid hydrocarbons which can be used as petrol and diesel in the petrol and diesel engine. In the modern version of Fischer-Tropsch synthesis, even we can convert carbon dioxide and H2 into liquid fuels. If we can produce the hydrogen in large quantity from the renewable source of energy like solar radiation, then that electric current produced from the solar radiation can be used to produce hydrogen from the water, and carbon dioxide which is released to the atmosphere from the chemical industries that can be trapped, and carbon dioxide and H2 can be subjected to Fischer-Tropsch synthesis for the formation of liquid hydrocarbon fuels, which can be used as alternatives to the fossil fuels. Another way of converting biomass into liquid fuel is through biodiesel production. So all fatty resources, whether it is originating from the vegetable resource or from the animal resource, all fatty resources can be converted into diesel, what we call it as biodiesel. All fatty resources, they mainly contain triglyceride. Triglyceride is a bigger molecule. The size of this molecule is almost 3 times higher than the size of the diesel molecule. And triglyceride, it can be subjected to transesterification reaction using methyl alcohol. And this bigger molecule can be broken down into 3 smaller molecules. Size of this methyl ester of the fatty acid, it is very similar to the diesel molecule. And it has all the properties very similar to the fossil fuel diesel. And it can be used as alternative to the diesel. And this we call it as biodiesel. And biodiesel, you can see here, there is ester group here. And there are 2 oxygen atoms. And presence of these 2 oxygen atoms improve the combustion properties of the diesel. And biodiesel can be used in the diesel engine without any modification of the engine. And also the quality of the biodiesel is very much higher when compared to the quality of the diesel. It has higher C10 number. And emission of pollutants from the diesel engine can also be reduced using biodiesel in place of the diesel. The common catalyst used in the biodiesel production is sodium hydroxide, which is a homogeneous catalyst. And a lot of research is going on to find a proper heterogeneous catalyst, which can be separated from the reaction mixture very easily to carry out the biodiesel production. And a lot of catalysts have been already discovered. And this reaction, it can be carried out not only using the sodium hydroxide like base catalyst, it can also be carried out by using acid catalyst. And a lot of research is done to find a proper heterogeneous catalyst. But these heterogeneous catalysts, they are not yet commercialized, and we need to commercialize the process. And moreover, as of today, biodiesel is being produced in the batch reactor, batch by batch. And we need to go for the continuous biodiesel synthesis using continuous reactor. If at all, we need to use biodiesel commercially. Another way of converting biomass into liquid fuel is through biochemical process, fermentation, production of bioethanol from fermentation process. We all know the procedure for conversion of the production of bioethanol from the sugarcane industry. The waste of the sugarcane industry, molasses, it can be subjected to fermentation, resulting in the production of bioethanol. The ethanol produced from the sugarcane industries, it is called as first generation ethanol, bioethanol. And a lot of research is going on about producing second generation, third generation ethanol from corn and cellulosic biomass, which are available in plenty. And here also similar reactions are carried out. Only thing is you need to subject this biomass into pre-treatment and then to hydrolysis, treating with the enzymes and acid, and then fermentation, resulting in the formation of ethanol. This bioethanol, it can be blended with petrol and can be used as core alcohol in the petrol engine. We can blend up to 5 to 85% of bioethanol in petrol, and we can minimize the usage of petrol in this way. We can blend the bioethanol in petrol, and we can use that mixture as a fuel in the petrol engine without any modification of the engine, up to 15% of blending. And if you want to blend more than 15%, you need to go for appropriate engine modification. As of today, in India, in the year 2020, we are blending up to 7% of bioethanol in the petrol. These are the 4 chemical routes for converting the solid biomass into liquid fuels, which can be used as alternatives to the fossil fuels. But one of the major drawbacks of all these fuels is they all contain carbon, and they all emit carbon dioxide into the atmosphere. Therefore, we need to find the ways to minimize the emission of carbon dioxide into the atmosphere, because carbon dioxide is the main gas responsible for the global warming. And there are multiple options for reducing emission of carbon dioxide in the atmosphere. The The first particular option is using the carbon containing fuels efficiently. And second option is carbon capture, utilization and storage. And third and real option is using a non-carbon containing fuel like hydrogen. Let us see the first option here. See, we are getting about 90% of the energy requirement of today by burning of carbon containing fuels. And here we are obtaining energy from the carbon containing fuels by direct combustion of the fuel. And when direct combustion of the fuel is carried out, the chemical energy present in the fuel, it is converted into heat energy, and that heat energy is converted further into mechanical energy or electrical energy. Therefore, there is loss of energy in each and every step of conversion. And hence the efficiency of conversion of chemical energy into heat energy and then into electrical and mechanical energy, it is very less. For example, if you take a thermal power plant, in thermal power plant, the coal is the main source of energy. The chemical energy present in the coal, it is converted into heat energy on combustion of the coal sample. And that energy is transferred to the water for production of the steam. And steam is used for rotation of the turbine. And by rotation of the turbine, electrical energy is produced. And here you can see here, there is loss of energy in each and every step of production. All the chemical energy present in the coal is not converted to heat energy. And all the heat energy present in the coal is not completely transferred to the water. And all the heat transferred to the water is not completely transferred to the steam. And similarly, there is loss of energy in each and every step of production. Moreover, after production of the electric current, during transmission of the electric current, there is again loss of electric current. Therefore, the overall efficiency is very less. Overall efficiency of the thermal power plant, it is only about 35%. Similarly, in case of petrol and diesel engine, where the fuel is burnt and heat energy released during combustion of the fuel is used for the running of the vehicle, there also there is loss of energy and efficiency is very less. Efficiency of all this combustion process is limited by Carnot cycle. Therefore, we need to look for the alternative way of using the energy, chemical energy present in the chemical fuel efficiently. So in the combustion process, what happens here is the chemical energy present in the carbon, it is converted into heat energy by combustion of the carbon into carbon dioxide. This conversion of carbon into carbon dioxide, actually it is the oxidation process. And as we all know, in the oxidation is the process of loss of electrons by a chemical species. Electrons are liberated in the oxidation process. And we know the definition of electric current. An electric current is nothing but flow of electrons. And electrons, they flow from one point to another point, only when there is difference in potential between 2 points. Therefore, all the chemical fuels, instead of subjecting chemical fuel to combustion directly, we can oxidize the chemical fuel and use the electrons which are liberated in the oxidation process, and we can convert the electrons which are liberated in the oxidation process into electric current directly. If we can convert in this way, then there is no loss of energy here. All the chemical energy present in the fuel can be converted into electric current directly. For this, we use a device which is called as fuel cell. Fuel cell is a device which is used to convert the chemical energy of the fuel directly into electrical energy by chemical oxidation of the fuel and not by combustion of the fuel. In the fuel cell, what we do here is fuel is passed over the anodic compartment, and this is the working of the fuel cell. Here you can see here, the fuel is supplied over the anodic chamber where the fuel is oxidized and electrons are liberated. These yellow dots which are liberated here, they are the electrons, and those electrons, they flow from anode to cathode compartment through the external circuit, and at cathode, oxygen from the air is used as the reactant, and oxygen is passed over the cathode electrocatalyst where oxygen is reduced, and this simultaneous oxidation reduction reaction occurring in the anodic and cathodic chamber, where electrons are liberated in the anodic chamber, consumed in the cathodic chamber. We can obtain the electric current from this particular process. And here, fuel is oxidized, liberating electrons, and the chemical energy present in the fuel is directly converted into electrical energy. What we need in the fuel cell is a catalyst, which can oxidize the fuel efficiently in the anodic chamber. Similarly, we need a catalyst which can efficiently reduce oxygen in the cathodic chamber. If you have a catalyst which can oxidize the fuel with 100% efficiency, then all the chemical energy present in the fuel can be converted into electrical energy directly. That is one of the major advantage of the fuel cell. Fuel cell, theoretically, it can convert all the chemical energy present in the fuel into electrical energy. Therefore, one of the major advantage of the fuel cell is conversion efficiency of a fuel cell can be theoretically 100%. And if you can achieve this conversion efficiency, then the efficiency of the working of fuel cell will be almost 3 times higher than the efficiency of working of a thermal power plant. And moreover, in thermal power plant, one of the major drawbacks is thermal power plant is situated in some part of the country, and after generation of electric current there, we need to transport the electric current from there to different parts of the country. But that problem you can overcome in case of fuel cell, because in fuel cell we can produce the electricity on the spot, and therefore there is no problem of transmission and distribution of the electric current. And since fuel cell works with higher efficiency, almost 3 times higher than the power plant, we can reduce that much amount of emission of carbon dioxide. And in fuel cell, we can use a majority of the fuels what we use in thermal power plant. Coal can be gasified and can be used as fuel in the fuel cell. We can use liquid fuel like petrol and diesel. We can use alcoholic fuels like methanol, ethanol, and also we can use hydrogen as a fuel. And fuel cell, sorry, fuel cell, when we use hydrogen as a fuel, then there is no emission of carbon dioxide at all. When we use carbon containing fuel, we can reduce the emission of carbon dioxide. But when hydrogen is used as fuel, then there is no emission of carbon dioxide. And fuel cell can be used for large scale production and small scale production of the electric current. And hence, fuel cell can replace petrol and diesel engines. We can use fuel cell in place of the petrol engine and diesel engine and produce electric current on the spot and use that electric current for running of the electrical vehicles. And as of today, varieties of fuel cells are available with a wide range of operating temperature and different varieties of fuels and with different electrocatalysts and different electrolyte and different working temperature. Out of all these fuel cells, hydrogen oxygen fuel cell is already in commercial use. And in hydrogen oxygen fuel cell, we use polymer electrolyte membrane as electrolyte. And this fuel cell, where the hydrogen is used as fuel and platinum is used as anode catalyst. And this fuel cell, it works without emission of carbon dioxide into the atmosphere. Here is the comparison between a fuel cell run electrical vehicle and a battery powered electrical vehicle. Today in India, we have battery powered electrical vehicles, and these battery powered electrical vehicles are being marketed as green vehicles. But if we closely observe these battery powered electrical vehicles, they are actually they are not green vehicles. A green vehicle will be that vehicle where the electricity required for running of the vehicle, it is supplied by the fuel cell operated by using hydrogen as a fuel. Because in case of battery powered electrical vehicle, the battery commonly used is lithium ion battery, and lithium ion battery is a secondary battery. Actually, battery, it is not a source of electric current. It is a device which can store electric current. And battery, after each and every usage, we need to recharge the battery. For recharging battery, we use the electric current. In India today, more than 85% of the electric current what we are using, it is coming from thermal power plant, where carbon dioxide is released to the atmosphere. Therefore, if you are using that particular electric current for charging of the battery in the battery electrical vehicle, and during charging of the battery, there will be loss of energy. And during discharging of the battery, again, there will be loss of energy. Therefore, there will be the efficiency of the energy what we use in battery powered electrical vehicle. It will be lower than the efficiency of the electric current what we are getting from thermal power plant. Therefore, a battery powered electrical vehicle, it is not a green vehicle. It is contributing for release of carbon dioxide into the atmosphere somewhere else. Therefore, a real green vehicle will be a vehicle where fuel cell is used as source of electric current. And there are many advantages of a fuel cell powered electrical vehicle when compared to a battery powered electrical vehicle. One of the major advantages is the refueling time of fuel cell electrical vehicle is only 3 to 5 minutes, similar to the petrol car and diesel car. Whereas in case of battery powered electrical vehicle, we need to recharge the battery for about 4 to 6 hours. After one recharge, we can use the battery powered electrical vehicle only up to 100 to 200 kilometers, depending upon the battery capacity. Whereas a fuel cell powered electrical vehicle, after each refueling, we can use it up to 600 kilometers. And overall life of the battery powered electrical vehicle, it is limited by the cycle life of the battery. We all know about the cycle life of lithium ion battery. Whereas fuel cell, we can use it for longer duration. It can work up to 2 lakh kilometers. The only problem is the present day fuel cell run electrical vehicles, the cost is almost double that of the battery powered electrical vehicles. And this is mainly because of the platinum metal which is used as electrocatalyst in the fuel cell run electrical vehicle. And another drawback is when we use platinum metal, we need to use pure hydrogen as a fuel. And hydrogen should not be containing any carbon impurity like carbon monoxide, which is the catalyst poison for the platinum metal. And with the newer technologies, and we can reduce the loading of platinum metal in the electrocatalyst, and we can reduce the cost of the electrocatalyst. And it is estimated that in the year 2030, by year 2030, cost of the fuel cell run electrical vehicles will be very similar to the cost of the battery run electrical vehicles. Here is the comparison between fuel cell run electrical vehicles and battery powered electrical vehicles, which are commercially available in the market. Fuel cell run electrical vehicles are released to the market in the year 2014. You can see the range of working year. For each refueling, a fuel cell run electrical vehicle, it can go up to 500 to 600 kilometers. Whereas a battery run electrical vehicle, except this particular model, Tesla model, which can go up to the 300 to 426 kilometers. But all other battery run electrical vehicles, they have the range in between 100 to 160 kilometers. Therefore, see, fuel cell is a device which can be used to convert the energy, chemical energy present in the fuel efficiently and effectively into electrical energy. And that too in the fuel cell, if you use hydrogen as a fuel, then the combustion product is water, which is not a pollutant. Therefore, we can prevent the emission of carbon dioxide into the atmosphere in a more efficient manner. Therefore, for all the carbon containing fuels, the only real alternative chemical fuel is hydrogen. Because hydrogen is the only fuel where there is no carbon. Combustion product of the hydrogen fuel is water, which is not a pollutant. And hydrogen, it can be used as fuel in the fuel cell for generation of the electric current in efficient manner. And also, hydrogen, wherever we need the chemical fuel for heating purpose, and there we can use the hydrogen for heating purpose directly. Energy content of the hydrogen, this is one of the major advantage of hydrogen. Energy content of the hydrogen, it is 122 kilojoule per gram, which is almost 2.75 times higher than the energy content of the hydrocarbon fuels, liquid fuels like petrol and diesel. But before we start using hydrogen as a fuel, there are major challenges which we need to overcome. One of the major problem is hydrogen is a colorless, odorless gas. See, suppose if there is any leakage in LPG, we can detect the leakage only by smelling the odor of the LPG. But hydrogen is an odorless gas. And another major drawback is hydrogen is a secondary source of energy. There is no primary source of hydrogen. Hydrogen needs to be produced by some chemical reaction. And while producing hydrogen, for hydrogen to be used as fuel in the fuel cell, we need clean hydrogen, hydrogen which is free of any impurity. Even if we can produce the clean hydrogen, the major problem with the hydrogen is highly explosive. It is highly inflammable. Ignition temperature is very less. Therefore, one of the major problem is storage, handling, and transportation of the hydrogen. As of today, the infrastructure is very well built for handling of the liquid fuels like petrol and diesel. We have the facility for production of petrol and diesel from the crude oil, and we have the facility for the transportation. We have petrol bunks for supplying of the petrol and diesel. But for hydrogen, we don't have any facility. Therefore, before we start using hydrogen as a fuel, we need to rebuild the whole facility for production of the clean hydrogen, storage of the hydrogen, handling of the hydrogen, and transportation of the hydrogen. Let us see what are the methods which are commonly used today for production of the hydrogen. See, about 96% of the hydrogen what we are producing today, we are getting from carbon containing resources. This is very unfortunate. Hydrogen, we consider it as a pure fuel where there is no carbon. But for production of the hydrogen itself, we depend upon the carbon containing resources. One of the major reaction is reforming reaction. Reforming of the natural gas or by partial oxidation of the heavier hydrocarbons, we can obtain the synthetic gas, carbon monoxide and 3H2. And hydrogen is part of this synthetic gas here. And carbon monoxide, which is formed over here, through water gas shift reaction, it can be further converted into hydrogen. These are the catalysts which are commonly used for the water gas shift reaction. Iron chromic oxide catalyst, copper zinc oxide catalyst. This particular catalyst, it works at lower temperature when compared to this catalyst. And newly, they have discovered one particular catalyst, platinum molybdenum carbide, which is doped on aluminum oxide. And this catalyst, it has higher efficiency compared to these two catalysts with 44% conversion efficiency, and it works even at lower temperature of 180 degrees centigrade. And in future, this particular catalyst will be used in the water gas shift reaction. These are the two methods of production of hydrogen from the carbon containing resources. As of today, we are getting about 96% of the required hydrogen from these carbon containing resources. Major drawback of the carbon containing resources is the hydrogen what is produced from the carbon containing resources, it invariably contains carbon monoxide, which is the catalyst poison for the platinum metal, which is used as the electrocatalyst in the fuel cell. Therefore, for using hydrogen as a fuel in the fuel cell, we need pure hydrogen. And the only source for pure hydrogen is water, H2O. H2O, it can be split into H2 and O2. This looks to be a very simple reaction. H2O can be split into H2 and O2. But this is one of the most difficult reaction in chemistry because energy required for splitting of H2O into H2 and O2, it is very high. About 237 kilojoules of energy is required to split 1 mole of H2O. And in terms of the potential, we need about 1.23 volts of potential for splitting of the H2O into H2 and O2. And therefore, even though we have the technology for electrolysis of water, for conversion of H2O into H2 and O2 using electric current, it requires a lot of energy. Therefore, if you use the electric current which is coming from thermal power plant with the efficiency of 35% for splitting of water into H2 and O2, and there is no meaning in using this particular H2 as fuel in the fuel cell because the efficiency, it will be negative efficiency. Therefore, we need to look for the alternatives. where we can produce the hydrogen gas, pure hydrogen gas, by splitting of the water efficiently. The one way is if we start producing electric current in a cheaper manner and more amount of electric current from a renewable sources like solar energy, then that type of electric current can be used for splitting of water using electric current. Another method of producing splitting of water is using photoelectrocatalyst. There are wide variety of solar materials which have been investigated and which can split H2O into H2 and water. Oxides, nitrides, carbides, sulfides, silicon, arsenide, carbon nanostructures, organic, inorganic co-catalysts have been reported as effective photoelectrodes, anodic and cathodic materials for splitting of H2O into H2 and O2 in the presence of solar radiation. But majority of the solar materials, majority of these photoelectron materials, they have solar to hydrogen efficiency of only less than 5%. But for commercial usage of these catalytic materials, a catalytic material must have solar to hydrogen efficiency of more than 10% and stability should be more than 1000 hours. And if you can find a catalyst where the STH value is more than 10% and stability is more than 1000 hours, then that type of catalyst can be used for direct splitting of H2O into H2 and O2 by using solar energy, and that H2 can be used as fuel in the fuel cell. Therefore, ultimately, for using hydrogen as a fuel, we need to produce hydrogen from a real alternate energy resource, and the only real alternative for the carbon containing fuels what we are using today is the solar energy. And if we can produce the electric current cheaply from the solar energy, that electric current we can use for splitting of H2O into H2 and O2, and which can be used as fuel in the fuel cell, and so that we can completely eliminate the emission of carbon dioxide into the atmosphere. Solar energy, it is available in plenty. As per an estimation, the solar energy received by Earth's surface in a single day, it is sufficient to meet the energy requirements of the whole world for about 16 years. And the main way of using solar energy is converting solar energy into electrical energy. And as we all know, device used to convert solar energy into electrical energy, we call it as solar photovoltaic cell. Energy spectrum of solar energy, it is in the range of 0.5 electron volts to 2.9 electron volts. And therefore, any material for that matter, which can absorb the solar energy in this particular energy range and emit the electrons, can be used as a material in the solar photovoltaic cell. There are number of materials available which can absorb the solar radiation of this particular energy spectrum and emit the electrons. And not only they should be able to emit the electrons, the second requirement is there should be difference in potential across the material so that electrons they flow from one point to another point and producing electric current. There are many materials available which satisfy these conditions. As of today, we are using first generation photovoltaic cell. About 95% of the electric current what we are producing from the solar energy, it is using these first generation photovoltaic materials which are based upon silicon material. We use crystalline silicon, single crystalline silicon, multi-crystalline silicon based solar photovoltaic cell today for conversion of solar energy into electrical energy. These are the first generation photovoltaic cells. There is a major drawback of this first generation photovoltaic cell. Even though silicon is available abundantly, the cost of the silicon required for the production of photovoltaic cell is of very high purity. 6N purity silicon is required here, and cost of production of that 6N purity silicon is very high. Therefore, the overall cost of the resulting material is very high as of today. But lot of research is going on in finding different varieties of other photovoltaic cells. And all these photovoltaic cells, they come under the category of thin film solar photovoltaic cells. In thin film technology only, there are second generation photovoltaic cells third generation photovoltaic cells and the fourth generation photovoltaic cells. In the second generation photovoltaic cells, we use the metallic materials, combination of different metallic materials and non-metallic materials like copper, zinc, tin, sulfur, cadmium, tellurium, gallium, etc. in the production of the photovoltaic cell. In the third generation photovoltaic cell, there are three types: quantum dot photovoltaic cell, organic photovoltaic cell, desensitized photovoltaic cell. In the fourth generation photovoltaic cell, there are two types: hybrid nanocrystals and perovskites. These are the solar photovoltaic cells which are which have been discovered already, and as of today we are using the first generation photovoltaic cell for production of the electric current mainly. In future we'll be seeing all these photovoltaic cells in the commercial use for conversion of solar energy into electrical energy. As we move from first generation to second generation, third generation, fourth generation, the cost of production of electric current from the solar energy will be decreased. And this is the estimation here. By 2030, the electricity cost which is produced from the solar photovoltaic cell, it is projected to decrease by about 50% by the year 2030. And cost of the electric current produced from the solar photovoltaic cell is going to decrease exponentially in the coming years. And if this happens, then this is the main critical point here. To achieve the goal of pollution-free world, we need to produce the electric current which is sufficient to meet all the requirements of the world without using carbon-containing material and without emitting carbon dioxide into the atmosphere. And for achieving this particular goal, solar photovoltaic cell is going to play the major role. And leading from the front, the solar photovoltaic cell, we can use other energy resources where there is no emission of carbon dioxide into the atmosphere. We can use the hydropower, geothermal power, nuclear power, solar thermal power, wind power, and ocean energy for producing electric current directly without emission of carbon dioxide into the atmosphere. If you can produce the electric current in a cheaper manner, cheaper than the electric current what we are producing today in thermal power plant, by using other resources without emission of carbon dioxide into the atmosphere, then in that particular case, we can imagine a world where there will not be any pollution. In that case, whatever the electric current we produce here from these resources, we can use the electric current extensively. Wherever we can use electric current directly, we can use, for example, for the transportation purpose, in the industries, in the buildings, we can use this electric current directly. And the excess electric current which is produced by renewable sources of energy, mainly from the solar energy, solar photovoltaic cell, can be used for splitting of water into H2 and O2 in the electrolyzer and for production of the hydrogen. And hydrogen produced in this way, even though we need a lot of electrical energy for splitting of H2 into H2 and O2, if the electric current is coming cheaply from the solar energy, then that electric current can be used for splitting of H2O into H2 and O2. And this hydrogen, it can be used as fuel in the fuel cell, which works more efficiently for production of the electric current, where we can convert the hydrogen, chemical energy of the hydrogen directly into electric current. And it can be used for running of the vehicles, running of the ship, running of the train, running of all type of vehicles. We can use the hydrogen oxygen fuel cell. And hydrogen can also be directly used wherever we need hydrogen for the heating purpose. Hydrogen can be used as fuel directly. Hydrogen can be used in chemical industries for the transformation of chemicals, and hydrogen can be used for domestic purpose in the building and also for the power generation. Therefore, for achieving pollution-free world, we need to establish the hydrogen society where hydrogen will be used as chemical fuel wherever we need hydrogen as a fuel, wherever we need hydrogen as a source of heat energy. And hydrogen will be used as a fuel in fuel cell for producing electric current on the spot, wherever we need electric current on the spot. And with these two technologies, with these two ways, we can completely eliminate emission of pollutants into the atmosphere, and we can imagine a world where there will not be any pollution. So as per the estimation of International Energy Agency, we are going to achieve these things in the year 2060. By year 2060, the emission of carbon dioxide into the atmosphere will be nullified. This is the year where we are going to achieve the target of zero emission of carbon dioxide. You can see here, different countries will be achieving this particular goal in different time period. The Asian countries are going to be the last, which are going to achieve this particular goal in the year 2060. Similarly, different chemical industries are going to achieve this particular target in different years. The steel industry, which is contributing to more emission of carbon dioxide into the atmosphere, will be achieving this particular goal in the year 2060. Lot of progress is going on throughout the world for achieving this goal of pollution-free world and for establishing hydrogen society. One of the leading countries is Japan. In the Japan, they were the first to introduce the fuel cell run electrical vehicle in the year 2014, and they have established hydrogen refueling stations in the year 2014 only. And by year 2030, they are planning to establish hydrogen power plant. And Japan has the target to produce the hydrogen without using any carbon containing resources in the year 2040. And that hydrogen, which is free of carbon emission, we can consider it as a pure hydrogen. And that economy, we call it as hydrogen economy. And hydrogen economy is the key factor for achieving the pollution-free world. Another important thing is here, the Tokyo metropolitan government, it has set a target of uh, uh, carbon dioxide free hydrogen power source for using of hydrogen as the source of energy in the ensuing Olympic Games. In the Olympic Games, they have the target of the achieving this zero emission of carbon dioxide. All the vehicles which are going to be used in the Tokyo Olympics will be run by the fuel cell where the hydrogen is used as fuel. And throughout the event, only hydrogen will be used as source of energy. And in this way, Japan is moving towards establishing hydrogen society during the ensuing Tokyo Olympics. Similarly, other countries they are putting a lot of effort in transforming from this carbon-containing fuels into from the carbon-containing fuels to hydrogen-containing fuel. China has already set target of producing 1 million fuel cell electrical vehicles, where the hydrogen is used as fuel by the year 2030. And a Swedish project, which is called as Hybrid. Hybrid is hydrogen breakthrough iron making technology. See, presently in the steel industry, for production of the iron, for reducing of iron ore into iron, we are using carbon as the reducing agent. This particular project is the first project which is going to operate from 2020, from this year. And this project aims to use hydrogen as a reducing agent for reducing iron ore into iron metal. And this is the first such project where the iron will be produced without using any carbon containing material and without emission of carbon dioxide into the atmosphere. And another example is Dubai Electricity and Water Authority. It is establishing first solar based hydrogen electrolysis facility, and this facility will be producing hydrogen by using solar energy, that is by using the electrical energy produced from the solar energy. And another example is the Mokai geothermal power plant, which is established in New Zealand, and it will be operating from this year. And this particular project, it will be producing hydrogen by electrolysis of water by using the geothermal power. And the hydrogen, they have the memorandum MOU with the Japan, and the hydrogen which is going to be produced here it will be transferred to the Japan directly through the pipeline. And this is the first example of conversion of geothermal power into hydrogen. Lot of examples are there where different countries they are progressing towards making this world pollution free. And the main way of making this world pollution free is using hydrogen as a fuel, and that too clean hydrogen. And clean hydrogen which is produced from the electric current which is produced from the renewable source of energy, mainly solar energy. Therefore, the solar photovoltaic cell which can effectively convert solar energy into electrical energy, and then splitting of H2O into H2 and O2 using electric current produced from the solar energy, or using the photocatalytic material which can split the H2O directly into H2 and O2, and using that hydrogen as a fuel in the fuel cell, and using hydrogen as a fuel wherever we need fuel directly for the heating purpose. If you follow this particular base, then these are the real alternatives which will make our world pollution free. And all these things are achievable. And by year 2050-60, we'll be having the world where there is no pollution, where vehicles will be running without emitting any pollutants, without making any sound, and all the industries will be working without emitting any pollutants. And we can imagine the world where there is no pollution. With this, I'll end my talk with a slogan: let us be a part of solution and not pollution. Thank you.
Thank you, sir. It was indeed a very informative session. Sir, we have certain doubts from the participants. We will be happy if you could answer them.
Please, madam.
The first one is from Bisal Sarkar. The first question is, can fuel cells be used in electric vehicles?
Fuel cell, yeah, fuel cell is a device which can produce the electric current on the spot. Therefore, when fuel cell is used in electrical vehicle, then there is no requirement of charging. Charging, discharging problem will not be there. We can produce the electric current on the spot by using fuel, and that electric current is used in the running of the electrical vehicle.
Okay.
And in fact, as I discussed, that is the that is going to be the real green vehicle when compared to the battery powered electrical vehicle, because there are so many problems with the battery powered electrical vehicle, and all those problems we can overcome once we have fuel cell electrical vehicle.
Thank you, sir. The next question, is there any substitute for platinum electrode?
Yeah, a lot of research is going on about finding cheaper electrocatalyst. But major problem is in the fuel cell there are three types: low temperature fuel cell, medium temperature fuel cell, and high temperature fuel cell. High temperature fuel cell like solid oxide fuel cell, there we can use non-platinum electrocatalyst like nickel and other transition metals can be used as catalyst. But there we have to go for high temperature. Operation temperature should be very high. But low temperature fuel cell, those catalysts are not working properly. And here we have to go for the platinum based catalyst, but in the low temperature. That's the main problem.
Okay, thank you, sir. The next question is Mr. Manoj. Can clean energy replace fossil fuel?
Yeah, it is going to replace. Definitely. That is what I said. In next 30-40 years, with these alternate energy resources, we'll be having the world free of pollution.
Sir, the next question is biomass derived fuel economically feasible?
It is economically feasible once the cost of production, when it becomes lesser than the cost of production of present day fossil fuels. Because present day fossil fuels, what we have today, the rate is fluctuating too much. Before 5 years, the cost of the crude oil was around $140 per barrel, and now it is around 40-50. Therefore, all these alternatives will come into the picture only when the fossil fuels they get exhausted.
Okay. So the next question is from Mr. Ramesh Madhegowda. For hydrogen being used as a chemical fuel, certain limitations are faced. How to overcome these limitations?
Yeah, madam. The main limitations, as I discussed, main limitation is production of clean hydrogen, and after production, storing and handling is highly difficult. And lot of research is going on. Japan is the leading country. They've already produced a lot of materials, safety materials for storing and handling of the hydrogen. Automatically, technology will be transferred to other countries.
Okay, thank you, sir. With this,
Thank you, madam.
with this, we can end up like it was really an eye opener into the advanced progression in the field of fuels. And I think that this was a clearly and nice explanation, making planning easier. And truly, the topic which has to be discussed at the present scenario. Thank you for making us more informative about this. We hope that you will be joining us for further webinars also. Thank you for your valuable time, sir. Thanks again.
Thank you, madam.